Anvilogic Blueprints let your team take any SOC workflow you're running manually today and turn it into repeatable, AI-driven automation. Today, continuous detection validation. You run attack simulations, and the results show you exactly where your coverage has gaps, real attack paths with nothing watching them. This blueprint closes those gaps. It turns a missed simulation into a deployed detection in minutes, with your team approving every gate. This starts in SafeBreach. I ran a simulation for credential harvesting techniques, and some of the attack types, system information dump, data collection, were not detected by any of my detection controls. No detections exist for these. These are validated gaps. SafeBreach ran the attack in my environment and nothing fired. So the job is to turn these misses into new detections, and we do that with a blueprint. This is the SafeBreach Simulation Detection Blueprint. Step 1. Intake the simulation results and find what was missed. Then it builds a detection design from that information. Authors the detection query and tests it against real data. Creates the threat identifier inside the Anvilogic platform and deploys it. One blueprint, running that whole multi-step process, SafeBreach misses in, deployed detections out. To kick it off, all I give it is the simulation URL. It presents the plan, the steps we just saw, and I confirm. Step 1. Retrieves the results from SafeBreach, pulls every simulation in the test, and summarizes the ones marked missed or that returned no results. What it's building is essentially an audit report of the test, what ran, where the gaps are, and where the detection opportunities are. And like every blueprint, nothing deploys without approval. The analyst confirms at each gate before the workflow moves. Here are the simulation results. The agent packages this into a knowledge artifact that gets passed to the agents downstream, the tests that ran, the ID, every simulation in it, and 2 priority candidates for new detections, credential harvesting from the registry and credential dumps. Critically, the artifact carries the raw event logs from the simulation, the actual command lines the attack used. That's the ground truth the detections get built from. Now the design phase. That artifact goes to the detection designer. First thing it does, before designing anything, is confirm these are actually gaps. It checks my existing detections and my maturity scoring to make sure nothing already covers these techniques. No duplicate work. Then it researches the techniques externally and builds a detection plan for each candidate. Here's the plan for the first detection. The techniques and sub-techniques it maps to. The behavioral evidence, the actual command line activity from the simulation, goals, background, documentation, and the raw event logs attached, so the builder has everything it needs. Same for the second candidate. And notice, it picked up on the tooling already in my environment. Microsoft Defender is turned on, so the plan anticipates what those logs will look like too. Now the plans go to the detection builder. This is the part to watch. The builder scours every connected data platform and searches all of my available feeds to pinpoint which dataset has the right information for each detection. Whatever the schema of your feeds, it understands my detection coverage, where my detections are deployed, and the schemas of my logs across every connected SIEM and data lake. This is what generic AI tools can't do. They're blind to your schemas and your deployed coverage. The blueprint starts from a platform that already knows both. Here it found valid feeds in my Azure dataset, Windows event logs, and Defender EDR logs, and it's sampling them, running queries, using the results to pick the best candidate for the build. First detection is done, and it landed on Splunk. My environment also has these event logs in Splunk, with better logging in place, so that's where it recommends building. On to the second. The second detection's data lives in a data lake in Snowflake, so it builds against Snowflake. Think about what just happened. 1 blueprint, 2 gaps, 2 detections. 1 Splunk, 1 Snowflake, each built where the right data actually lives. Your team didn't have to know which platform, which schema, or which query language, and you can execute and tune every query before anything deploys. The final build step converts those queries, SQL and SPL, into our detection as code framework. It documents each detection, why it was created, the data feeds involved, the query itself, and the explanation. This one's the Snowflake example. Then the AI operating system creates the detection inside the Anvilogic detection framework, with everything it needs to build it. Both detections are now in my staging environment. I can deploy or review first. Let's review. Here's the use case it made. MITRE mapping's done, descriptions written, and this is the actual rule logic in the detection as code framework. I'll pop it into test mode and run it over the last 24 hours. 2 hits. The detection works against real data, and now I deploy it down to my environment. Done. And every detection gets tracked in your maturity scoring framework, so you can keep validating continuously. Run the simulation again, confirm the detections fire, and keep the loop closed. To recap, SafeBreach found 2 techniques my controls missed. The blueprint confirmed the gaps, designed detections from the actual simulation evidence, built one in Splunk and one in Snowflake, tested them and deployed them, fully documented, MITRE mapped, human approved at every gate. That's continuous validation with Anvilogic. Every simulation run makes your coverage stronger. Book a demo at anvilogic.com, link below. From coverage gap to deployed detection in minutes.